Okay, hello. My name is Róbert Papp. Okay? Okay. I work for Trainline. I'm on the Android team. Trainline is a company that sells tickets on behalf of train and coach companies for 220 of them, actually, worldwide. We recently had the chance to review our UI tests and improve on them. And I will present what we came up with. Keep in mind that most of these are independent techniques, and you can apply them partially or in different contexts as well. Okay, the goals we set for ourselves were make the code easy to read. We wanted to hide the technical details, so it's just clear words what the test is intended to do, and the implementations are hidden. We wanted to make it easy to write, so we wanted to prevent mistakes, and we wanted the compiler to validate what we are doing. And the IDE should help us with really focused code completion at every point. And we wanted to make it easy to change, so when we are refactoring the layouts, the structural changes should be easy to change as well. And we wanted to make the code deterministic. We all know that flaky tests are bad, and we wanted to make it consistently reproducible, and we did it so by separating the external parties from the code. This is the structure of the talk as well. These will be the main sections. I will be using a hypothetical payment screen as an example. We are buying a ticket to Paris. You can select a payment method, and each of them can have a surcharge, and you can see the total, and if you press the pay button, then you get a confirmation screen of your successful payment, showing the destination and how much you paid. This is the end result we will end up with. I will go through every single word in this slide separately, because the DSL is quite complex. It's similar to Gherkin's step definitions. Everything is strongly typed, and it should be clearly visible what it does. If you read the code, you should be able to reproduce it yourself, all the assertions and actions that the test is doing. First, I will start with a quick recap of the Kotlin features I'm using. That code actually compiles. We will not be doing that. That's crazy. So starting with a simple function. There's a call function that does nothing, and there is a caller function that calls the other one. Both of these are in the global scope, and they are available everywhere. We want to restrict where functions are available, so we make the first one an extension function on a scope. That means that the called function can only be called when the receiver is in scope. For now, I will just add the parameter and call the function on there. Next, we can move this parameter to an implicit receiver. And that means that we can replace the parameter name with this. But this is optional, so we can just skip that. So we have a nice scope, and we can call the function, and that function will only be available inside that scope. So we are not polluting the global namespace anymore. And then now we add the functional parameter to this, and immediately execute that function that we pass in. This gives us a nested structure. And here we still have the outer scope inside the call function, but we can create its own scope, called inner scope. So now both functions have scopes, and they are nested, and that means that more functions will be available the deeper we go. That needs an instance to be passed in, so we create an instance of the scope. But notice that this inner scope is only used for scoping, so we don't need to create an instance every time. We can just convert it to an object. It has no state. So now I will go through how to start building the DSL from scratch. It's a really simple domain-specific language for UI tests. The motivation for this is Espresso code. It's not too readable. You don't need to read it. It's complex. That's the standard way of doing Espresso. The individual statements here are easy to read, but it's quite complicated to scan the whole thing as a whole, because there are many variables, they are visible, and it's not necessarily clear where they are being used. And if you have multiple tests doing the same thing, then you may end up with a lot of duplicate code. So this is the same test in the DSL. So first, I will start with creating the basic structure. This Gwen structure, some may be familiar with it. This based on Shazam's Gwen, which was written for Java unit tests. It's also using the language of the acceptance criteria, and the comment blocks that we had before. They become first-class citizens, and they give us a scope that we can use. Notice that when becomes whenever, because when is a keyword. The implementation of this function is quite simple. It's just a high-order function getting a lambda and executing it immediately. The given whenever then, exactly the same, just immediate execution. The major benefit is not visible yet. We will come back to improve this later. Next, we have collaborators. The collaborators are things which interact with the system, or they are a part of it. The user interacts with the app UI. Currently, it has no functions or anything. It just sits there. And we create the property which will be used for later. And then the collaborators can have actions. For example, the action is an interaction between a collaborator and the system. And the extension functions declaring the actions can only be used when the collaborator is in the scope. So we can only use the user actions when we have a user. In reality, in the end, we have the cease confirmation. That's a quite simple example. We can have multiple of those assertions. On the left, you can see that there are multiple assertions being checked, and we repeat the user dot multiple times. And we can help this by making the user invocable. That means that if you have an instance of a user, you can invoke it as a function, and that function gets a functional parameter, and there is an implicit receiver there for the user, so you can call it without qualification. There is still a repetition for Cs, so there are multiple actions being executed, and we noticed that there are multiple groups that come up. One of these was the Cs, that the user can see a lot of things, so we made this a group. This is a simple function as well, and now it's similar to the invoke function, but now it has a name and it's infixed, so we can skip the dot. This could be an extension function as well, but we decided to keep it together inside the collaborator because it helps with consistency. There could be multiple of these. The user can launch things, the user can select things, the user can also type into edit text. It's up to you if you use this, what you come up with. So in summary, this is the basic structure we have, and the nested structures are scoped to the scoped inside the main structure, and the collaborator is the implicit receiver there, and we use this implicit receiver to execute actions. So next, how do we make it easy to write? We wanted to use the IDE to its full potential, and we wanted to make the structure very strict so we can't make mistakes. So we started with this. It's a quite simple structure, but there is no scoping. These are just simple higher order functions. If we give each of them a receiver, so here we add the top level Gwen, we create an object and we pass it in, and that will be the implicit receiver. And then we can add the other ones as well, the same way. Notice that Gwen is now, the internal structure elements, the given whenever then, are now scoped to Gwen, so they are only accessible there. So the only global function we have left is Gwen. Now we can use these scopes to restrict the collaborators. So we can remove that global property for the user and create extension properties on the separate blocks. This is not quite useful for user because the user can be anywhere in the structure, but there are collaborators where it only makes sense to be available in specific scopes. For example, a server, we use the server as the collaborator to set up the stubbing. So it's only useful in the given block. We are not doing actions or verifications of the server. These properties are now extension properties, which means that they cannot store state, so we need the getter to be dynamic. At this point, we have the structure, and if we use the code completion inside the user sees block, then we see this screen. And you notice that there are 3 groups on the top, but we are already inside the sees block, so those are irrelevant at this point. And also that payment screen function is actually launching an activity. So if you put it in the sees block, then we get a weird behavior in the test, and we want to prevent this. The root cause of this is that the receiver of the sees function is the user. So if we change that and remove the user and create a specific scope for the C called Caesar sessions, then we can restrict which functions are available. We do the same for launches as well. And we can add the receivers for the actions. And at this point, we have a compile type check. We cannot launch a payment screen when we are verifying what is on the screen. There is a side effect here, which is that it also resolves name collisions, because we can have user sees a pay button, and the user can also select the pay button. And because these are now separate receivers, we can have the same name for the function. So now it's the same code, but with a different receiver, and now we get a really focused code completion. That was the goal. But now we have another problem, where imagine we add a new screen, and we add more DSL actions. In the example, I used the user profile screen. The avatar, email address, and logout button is for the user profile, but we are writing a payment test, so these are irrelevant here. We get mixed suggestions, and we can actually solve this as well. If we have a lot of imagine that we have 20 screens, this will be a really long list, so we need to restrict what's available. The solution is we wrap all the extension functions inside an interface. This will give us kind of a page object, and we can implement this interface in the test where we want to use it. And that means that the other functions, for example, launching the user profile screen, won't be available because we are in the payment screen test. But because it's an interface, we can implement multiple of them. And that way we can be picky in each test what we want to do. Okay. So this is how it looks like. In the payment screen test, the code completion gives us the payment-related stuff, and in the user profile test, we get the user profile functions only. This helped us with the collaborators being scoped, but the generic structure is still quite relaxed. We can write this, which is, I think it's wrong. It doesn't really show what we are trying to test. And we should use the compiler to help us figure this out. And we can do this by adding DSL marker annotation in it. The DSL marker annotation is applied to another annotation class. And if we use that annotation class to annotate our implicit receivers, then it will restrict where they can be, which extension functions can be called on them. So the given inside the other given will be a compile error, because the closest implicit receiver is arranger and not Gwen, and given is defined as an extended function to Gwen. Okay, so similarly, we have the user, the server, and the action groups, and these are also nested in a non-intuitive way, and we can also prevent this if we annotate the collaborators and the action groups with the DSL annotation. So at this point, all of our objects that are used for scoping the implicit receivers are annotated with the DSL annotation, and that prevents non-trivial nesting. So to sum up how to make the code easy to write, we added scopes to everything, so everything is inside the scope and provides a new scope. We use these scopes to annotate them with the DSL, and that means that we cannot access functions on higher level layers, and we added interface page objects, and we can be picky which ones we use. Next, how to make it easy to change. Here we can create multiple levels of abstractions. The top level abstraction we already saw. That was the UI test. The UI test is aware of the values that we are verifying, and it uses the DSL only. There is no Espresso code in the UI tests. And then we have the DSL layer, which is the interface with the actions, and their implementations are using Espresso. The DSL uses the business naming specific to the app, and it is aware of the screen structure. So it knows how the layouts are nested in the XMLs and what their IDs are. And the DSL uses Espresso. And then we have the bottom layer, which is the helpers, including Espresso itself. These are aware of the widgets, and they are independent of the app. The naming should be the Android SDK or UI specific, so button edit text, not what is on the actual UI. So it's not email address field, it's just edit text. And we can have modules, and that helps to separate these concerns, so the helpers wouldn't actually see the application code, so they can be written independently. So an example, on the UI test we say the user selects the payment method at position 1. This is the business naming. The payment method is on the screen, but the payment methods are implemented with a recycler view called payment methods. We look this up with Espresso, and then we use the click item extension function to click on a specific position. And the helper for this is the click item shown on the bottom, and that's using Espresso recycler reactions. These small helpers help to reuse code across screens. Another example, the user launches the payment screen. The payment screen DSL function is domain specific, and then we use the production code to create an intent. We pass it to the launch intent method, which is a reusable helper function that uses the instrumentation to actually launch the activity and gives the activity back to us if in case we need it. Now I will show an example where these layers could come in handy. The problem is the repeated items on the UI. So we have multiple payment methods, and we want to verify them independently of each other. So here we start with a simple action that will get the position, and then we add the lambda block, so we can put code inside, and then we add an implicit receiver. And this is where it's different from the other ones, because it's a class now, because it has state, and the state is what position we are working on currently. So now that we have a receiver and a class, we can add properties to it. And these properties will be used to validate the assertions that we want to see on the UI. So we are checking that the label is card and the fee is 0.5. Using properties here is useful for making it easy to read, because we are used to having data represented as properties and the actions represented as functions from object-oriented programming. So we declare a simple property, and we override the setter function. And inside the block, the ... would be the Espresso code that actually checks the UI element. Sadly, set-only properties are not a thing in Kotlin yet. So we need to provide default values, otherwise the code doesn't compile. And you can see that it's getting quite verbose now. We can actually reduce this verbosity with delegate. So here we replace the property initialization and the setter function with the delegate. This set-only delegate I will show next. So it's a simple function that returns a read-write property. Read-write property is a Kotlin class that is used for delegate declaration. It's an anonymous inner class of it. The get value function is called when you access the property and you try to get the value from it. But in this case, we want the getter to not work. It's in the DSL, if we actually access the getter, then we are doing probably something wrong, because we want to pass in a value to validate. So in that case, we just throw an exception. And then the set value function is called when the property is written. And this is where we want to put our assertion. And here is when I added the block for the code, and that block will be executed when the setter is executed, and we pass the value to the block, so we get the implicit it value inside the delegate, so we can actually act on the value that was passed in. And now the actual implementation of the property. There is 2 steps here. The first step is the inside method item function, which is used to look up a specific item inside a list item inside a recycler view. On item view is a magic function that returns us view interactions for the view interaction for that specific position and that exact view, and then we check the text inside the view. This separation is really important because it gives us a better error message. In if you use the built-in recycler view matchers, then the error message you get when you have a mismatch inside the recycler view item is that the expected test was something and the actual was a recycler view, which doesn't tell you what the actual text was. If you separate the lookup and the validation this way, then the error message will show you exactly what the UI element looked like. So in summary, we can create modules for the specific layers. We have the UI test, the DSL, and the helpers. We are minimizing repetition by using stateful DSL scopes. We separate the UI and the verification, and the helper methods are really small and focused. And we have increased readability over functions with the property setters. So next, we go through how we made the code deterministic. Normally, when you have an app and you run a test, it could be using the actual backend, but the backend can return data that's non-deterministic. We don't know what we will get when we do a search result for a specific date. So we cut that off, and we rerouted the app to use a stub server inside the instrumentation process, so it's running on the device, and we have full control over what it will return to us. And I will show next how we set up the DSL for this. I talked about the server Collaborator before, and it's only available inside the given block. And the server has an action group called stubs, which has the receiver set up. In this case, the setup is a class, and when we instantiate it, we could actually spin up the mock web server inside the constructor and have methods to set up the custom dispatcher. We are using OKHTTP mock web server for now. And next, this is the DSL. It's quite easy to read. When the server stubs the post endpoint, then we return a JSON from the raw resources. This is broken down into 3 functions. The post function will create a Hemcrest matcher that matches an OKHTTP mock web server recorded request. And that post method is only available inside the setup block. Same with the JSON. It gets the resource ID, reads the file from the resources, and creates a mock response. And then we have the glue, which is the with function. It's an infix function between the 2 objects. So it has a receiver, which is the matcher, that's the left side. It has a parameter, which is the right side. Infix means that we can remove the dot and the parentheses. And because it's inside the setup class, it is only callable when there is an implicit receiver set up in the scope. So all of these 3 things together can be glued nicely. And it means that the with method body will have access to all 3 parts. And this is quite extensible. We can write matchers and response creators any way we want. So just examples, we can do get post, we can validate the path, we can check what the request body is, and because these are Hemcrest matchers, we can also use the combinators from Hemcrest, like the all of, any of, both, either, to build more complex matchers. And then we have the different types of responses. So we can create a JSON from raw resources, we can create a PDF file from the assets, and we can even generate zip files on the fly. It's really up to what you need. Okay, so next I will go through the whole DSL again, but now this is the end result. So we have a DSL marker annotation, and we use this DSL marker on every single scoped object. We have a top-level function Gwen, that gives us a Gwen block. The Gwen block can contain 3 functions, the given, whenever, and then. And it gives us 3 separate receivers. We can use these 3 receivers to scope the collaborators inside them with the extension properties. The collaborator is a DSL object, and inside it has action groups. I omitted the code because it didn't fit. And we can have different collaborators. The user is just one example. We saw the server before. We can also have device to help set up intents, and we can use the configuration collaborator to set up the feature flags and A/B testing before we start the test. We are trying to minimize the number of action groups because there could be multiple things done with the synonyms. So, for example, the user could select, tap, or click, and all of these are kind of the same action. So it's easier to just have one selects block, but it's up to you which one you use. And then we have the DSL, which is inside an interface. We have a lot of extension functions. These extension functions will be scoped to the corresponding block. And they can also define their own receivers, which are also DSL objects. And inside there, we have the implementation for the assertions. And altogether, when we have all these, we can write a UI test like this. And it's important to remember that, like, what I showed you is the whole thing, but you can pick it to pieces and pick up whatever suits you best in your project. Okay, that's it. So I will push examples. I will push a working example into this repository, and I urge you to check out those U-track issues. Those will help to write us better DSLs in the future. One of them is multiple receivers, for example, so we can write extension functions with multiple scopes. Trainline is also hiring if you're interested, and join me afterwards if you have questions or want to give feedback on this, and enjoy your lunch. Thank you. Okay. Do you have a question? Okay.
Just here.
Okay.
You solved the problem of restrictions over scopes, but did you find a solution over restrictions about order of the calls?
I'm not sure what you mean. Other scopes?
I'm sorry, I will start.
The sound is really bad.
Did you find the solution over the order of the calls of the actions of the user?
Oh, well, you define your DSL with the individual actions, and then you have to make sure that it's in the right order. We can't really restrict the order. You can kind of influence the order by creating blocks like this. So if you create some nesting, so when you can create an action that launches a screen, and that inside that action you can set assertions, but then you would be mixing the whenever and the then blocks. So it's
okay.
Small functions are probably better, and yeah, you need to know the order.
Okay, thank you.
Okay, just here, in your assertion block,
Yes.
You cannot test the order of the action of the when you want. I mean, if you have 3 assertions, can you test the first is the first one and the second is really the second one?
Yes, with the positions. So this one. So notice that we in the payment method that function we pass in the position there. So I'm verifying here that there are 2 items. The first item is exactly this, and the second item is exactly that. So that position parameter to the function gives us which item we are working on, and then the name and the fee is validated for that specific row. Okay. There.
You've made the UI test layer independent from Espresso. Did you try to port this layer with Kotlin native to other platforms?
No. No. It's only Android. But yeah, it's just a raw Kotlin, so it should be possible. Yeah, okay. I guess that's it. Thank you.